define. Okay, yeah, okay. Let's go back. Oh, let's go return this. The live I was running. Okay, tonight this. Let's get back. I will show the last one information I put this. Okay, live stream. You watching the quantum computing simulation. This is different because today night I will use it a Qiskit framework, a quantum framework SDK 2.1.1 for running a series of the simulation using proposed bit flip on the experiment. The bit flip level is about 1.0. Many people, all researchers is using this system. They know this is, it means the chaos of in theory, but the system could be corrupt. But my symbiotic AI core, they can judge the quantum field is not an error but is an information. I call it a anti-ethical a field. But let's start. See this is my script. As you can see that my script is in Portuguese. For some reason I forgot to translate this one. Sorry, this a little mistake I did, but you can understand that this is a principal importation from my script is a external symbiotic AI which is responsible to solve it, to turn the currency. But now I will show this is more important. Now we have to show this. Look this. Any person would use this all the time and understand that this the noise 1.0 means a bit flip could be corrupted total system, but in this case we're not. This is a parameter to calc, but to calc the AI calc the currency, but it's based by entropy. Okay, is utilize the gravity to control the entropy on the systems. And let's finish it to be more impressive because this will take too much. I will have to take too much. This is the first one. Let's look and take the first simulation. I will do the first simulation using 120. Or could be or more if you want to. Let's start. I will use 33 qubits, 120 the first round. Okay, as you can see, this is the graphic has been generating on the first experiment. Its stability variance is about 0.3 and main stability is about 9%. And let's check this one. I will show the harmony. I created a specific, yes, this one. I created a specific script to show you how could the Harpy AI symbiotic AI identify the disharmonic rejected field. As you can see now, we have two different rounds. One round is red and the other one is green. As you can see on the top you have a legend. Is a comparative analysis of a SPI quantum system Qiskit. And as you can see on the graphic, this is the first graphic. Let's start one more using the same protocol. 30 qubits. Oh, we will use a little more. Could be 500. No, let's start 1, 2, 3. Is a 1, 2, 3. 2 is a kitty, little kitty. Okay, this is a the number is a little bit different once you compare the last one. Okay, 35. Not index of variance is not so much, but the name of the frame is accepted is a little different. Is once more. Okay, and let's start and check this one. The log the CSV. Let's check what. Let's check that. Okay, this is the proof of the theory is the quantum field is okay. The graphic is a little different. Oh, I will save the graphic to put the graphics. Oh no, you can do that by yourself. I put the code directly on the Google Drive for you, and you can use this harmonic a script to check it by yourself. And now let's start a big simulation compared with the last one. I will use 30 qubits. No, let's start 10 qubits and use it 1200. Okay. Oh, okay. This is the graphic is as you can see this is the way or the quantum field behavior once you're able the bit flip. I put a share if you a graphics, but if you wanted to see, I can do a simulation. This is one is my stop. Okay, that's good. I'll put go. I will show you. No, this one. Python 3. This is. I will show you a entangle for a entangle circ v4. This one. Okay, this is the behavior. The image you will see is the behavior. Or as you can see, this is a normal qubits behavior, and I will show this for a while. Is very normal. Now let's get back for the Qiskit and go once more simulation, and let's do it once more and using 30 qubits. I did 1000. Is about 1200 qubits. Okay. This one, and let's get check and the harmonic comparison graphics. Okay, this is one graphics. Well, let's see. Paste. Oh, do it again. Okay, as you can see that. Let me zoom it. It's very it's very predictable paths for any harmonic and disharmonic, and why you have a perception the quantum processor is feeling of many of interactions quantum field outside the or inside the same the same environment, including a total equipment, a total person inside, power supply, blah blah blah, etc. And let's check it. Let's zoom it a little more. This one, oh, I zoom it too much. Okay, as you can see that we have a green harmonic, and this harmonic is red. But this number could demonstrate that AI can she can learning, and you can be trained to identify this which is this harmonic. I will do not anything for a while because to me it doesn't make sense training anything using something else. We have a user the pattern which is registered for the computer. I needed to use a real computer to understand that, but I can do that. But I did this configuration. Let's go with test one more. I will do a not this one. No, one more try. I will use it 30 qubits, and let's start 12,100. or 12,000. Okay, this will take a little more, probably 10-20 seconds, less than 20 seconds. Okay, this code, as you can see, let's check the graphical, more harmonic, disharmonic. Okay, let's see that. As you can see that this is which is happening. Look at that on the top. Okay, as you can see that. Okay, you can change it if you are a good researcher. You've been and you understand which is this is a matplotlib, a graphical search. Yeah, you can use this. Is very common. And also let's start a little more to understand more. No, this one. Let's start. Okay, what uses 100,000. Okay, 30 qubits, 100,000. This will take a little more time because it's 10 times bigger when it compares when 1200, the 12,000. But it's pretty fast using a quantum symbiotic AIs. They can translate the quantum processing behavior, but the qubits, in my opinion, the qubits they are very strong. Okay, this will take less than 2 minutes. I don't know. Okay, that I have an idea. Could be less than 2 minutes, and but and on this night it is very important to me because I have to this is what I perceive what you call in the you call you call the interference. It is about is quantum fields interaction between many quantum fields. Okay, this is accepted. Okay, look, the variance is very good, and the main stability increase once you compare with the last one a little more. Okay, this is the graph. This let me show you something else. You have to see that. As you can see that this is entanglement behavior. People think the normal people thinks the qubits are identical like a twins. Not this is not possible. This is because is a nature a universal nature property is entanglement doesn't mean equal. Entanglement is you have a quantum fields interactions, but not interference directly on one another, but they can comprehend each other and they can support the same information. For example, you broken the it's very similar when you have a software broken in a process, but it is not equal because it in this case each quantum field processor use in different ways simultaneously. But more approximately you can understand is DNA. People think that DNA have a trash, but it's not that. In my opinion, it's not a trash. Okay, that's a lot of information. It's a huge and very important information about the environment. That this is the main stability. Okay, is on the black line, and now let's get check what the difference on the log, the variance. Okay, let's get check. Okay, as you can see, is more you can see the green points and the red points increase a lot more. And or you can see that there is disharmonic rejected is, and they have a straight line here is, and this behavior can be understood and comprehended in programmed on the machine learning, okay, to they learn everything. I was looking for a demo today, tonight, the slide, and I will have. That's good. I put. Oh, today I did a good simulation. Let me show you something else. I did a demo today, and this. Let's get this. The mod user the graphics a little more different, but it's very similar. Okay, which is the difference? The mode is more, the accuracy the mode is pretty high. Okay, this is only the mode. As you can see, of my simulations I use 14 qubits and 100,020 frames, and I had a 99.91% state accepted, and is a different. My perception is because that's why I built a AI called a Mason AI to correct this processes. But tonight I will not enter too much details. This is a data I will share with you, and I will, to be very clear with you, I will share this one, and I will share on front of you what I do now. Let me zone it is, and I will. They will ask me if I wanted to do a switch it. Okay. Okay. Okay, is updating. Now is 9:23 here. I have no idea why the modification is what this 9:23. Okay, this is I have no idea. It could be a Google clock. Okay, and you can check any of this one. I put the code here. This is a graphic harmonic generator, and you can use any AI you want to change or to produce any graphic generator for this one. And also on a Qiskit, this is IBM Qiskit, this same, and I've been trying to use a nuclear reactor is the Python 3 is here, and this is the simulation I did before. And I want to say to you thank you. My name is David Kubi. And this is my simulation for you. I will produce a paperwork, white paper, a new white paper with these simulations, including these simulations. But for tonight, this one is only a testimonial simulation of my symbiotic AI, who is responsible. And also, perhaps, once you do that, let's start a little the last one simulation for you. No, it's not a Qiskit. This is a bracket. Let's get a Qiskit. Okay. Let's start another one at 30. I will do let's start a 300,000. 300,000 using this. I will show my H-top. H-top. Okay, the script is running. Okay, using 142 megabytes. It's very scalable. Once you like you as you can see, it's very scalable because it's not using too much the processor. I put in my script limits a processor to use a maximum 90% total my CPUs, but using 4 processors, and because my CPU is i5 a 24 gigabytes RAM DDR4 DDR4 and I have not too much research to do that. I know people you think, oh, this is not possible. Is a new paradigm. Is a new paradigm. And yes, is a new ontological understand regarding the physical reality of the qubits. I understand these qubits. They are quantum fields, not a particle, and and also, oh, the way to control this qubits and guide it in, like a put a AI to guide them is using gravity. That's the reason why I use the gravity to conduce that. The same way, that's not my my point of view. I bring this information comes from a Einstein eclipse. He proves the gravity can conduce a a quantum a quantum effects from the light of the stars using his eclipse for pictures. But that's why I designed I create the formulation uses as phi using the gravity. Only you can see on my paperwork the same technique I use it to use it to run these processes. As you can see, the AI can identify which is a quantum bit, and and what each is the bit flip. Bit flip is not 100% a 185, but you can do the many of these things. This will probably take more. I have no idea, maybe 5-6 minutes. And sorry for late. I was thinking this was the song was being transmitting, but as you can see, my computer is not trained for this one. Let's check the utilization of my CPU. As I told you, the maximum can use it is 90%. Okay, you see that? This is my HTOP. I use in OBS and Firefox and Brave browser and blah blah blah. I'm sharing this one, and let's check this one. Oh, it's almost finished. Which probably would take 4 minutes. I believe in less than 4 minutes. It's very scalable, and I will provide once I decided not to publish the paperwork now, because firstly I think we have to do I have to provide the API for any researching. I will utilize my or is a Google is a cloud server to create this API, but I have to be honest with you. I have no time for this day to training an AI. Oh, this one, okay. As you can see, including the same, include the same. What is the difference between the mode? Okay, the number is reducing. The index of variation is reducing. If I use 3 million, this number you reduce or 0.01. Okay, but then we have no time to do that because 1 million it will take probably 27 minutes. I did this before. I okay, that's the graphic. You saw the similar graphic before, but let's see the harmony graph. The is generating. Okay. Oh, now you can see that this was in reality this graphic has to be represented in three-dimensional area. It's not possible to use it total area because the noises is represented by three-dimensional area. I've been trying to use to format this. I will try to find out the way to process this using a three-dimensional but that has to be animated, and using this particle or this point. Okay, this is it's end of the simulation today, and it will show you my screen. I will have a good idea. I will get this printing tonight. It will copy the log for you and share my desktop for you this way. This one, copy, and let's get through. Okay, and I will let's get the guard this.